change in the same way. So if I take each score and divide it by 2, then the sample mean is going to also be divided by 2. The median is a score that divides a distribution exactly in half. So it's not an average like the mean. Exactly half of the scores are less than or equal to the median, and exactly half of them are greater. So let's see how that works. The symbol used to describe the median is MD, and this is how we find it. If the number of scores is odd, so in other words, if we have five x values, 18, 24, 12, 2, and 14, this is what we do. We list the scores from low to high. And don't forget, this is just like a recipe. Just follow this recipe each time. So we line them up, 2, 12, 14, 18, and 24. And the middle score right here is the median. So MD, or median, equals 14. On the other hand, if the number of scores is even, then let's say we have an 18, 24, 12, 2, 14, and a 5. We've added a 5 now. We line them up from low to high, and now what do we do? Because there's no middle anymore. If we use 14 as the middle, we have 2 on that side and 3 on that side. What do? It's real easy. We take the mean of the 2 middle scores. So the 2 middle scores are 12 and 14. They each have 2 on either side of them. So we add up 12 and 14. It's 26. We divide that by 2, and we get a median of 13. MD equals 12 plus 14, which equals 26, divided by 2 equals 13. Pretty easy, huh? Okay, let's do an example of finding the median. You have the following distribution of weight in pounds among a group of people. Let's say they're people are Weight Watchers or something. 100, 250, 140, 210, 140, 300, 175, and 150. First thing we do is we put them in order. Then there is an even number of observations. So the median is equivalent to the mean of the middle 2 scores. Okay, so the middle 2 scores are going to be 150 and 175. We add them up. 150 and 175 equals 325. We divide them by 2, and because there's 2 observations, 150 and 175, and we come up with a median of 162.5. The mode is in a frequency distribution. The mode is the score or category that has the greatest number of scores, or the greatest frequency. Example, you have the following observations. Okay, 1, 6, 8, 4, 5, 4, 2, 3, 4, 2, and 4. The mode in this distribution is 4. There's a lot of 4s. There's a lot more 4s than any other number. It is possible to have more than one mode in a distribution, and if so, it's called a bimodal, or bi meaning 2, like a bicycle, a bimodal distribution. In a graph, the mode represents the peaks of the curve, and I wish I could draw for you here. I'm going to draw with my mouse. It'll be really bad, but I'm going to do it. So here's the peak of the distribution is right here, and that is going to be the mode. I'm writing like a kindergartner here because I'm trying to do it with my mouse instead of my stylus. Okay, so that's the peak of the distribution. That's what this big bold statement means. Okay, let's pop over. Okay, when do we use which measure of central tendency? The mode is used for nominal data. The median is used for ordinal data. The mean is used for interval or ratio data. How's that? And let's make a few other clarifications here. With skewed distributions, extreme values on either side of the distribution, the median, because the mean is affected by extreme scores. Example, income of everyone living in New York City, or offending rates. There are criminals who offend a lot more than people who don't offend. Or people living in New York City, you could have gazillionaires like Donald Trump, and then people who are out of work, not making any money at all. So with undetermined values, we'd use the median, because missing exact information, as an example, an amount of time to complete a test, we just don't know. And open-ended distributions, no upper or lower limit, we want to use the median, because missing exact information, again, we just don't know what the information is going to be. Measures of central tendency for three symmetrical distributions, normal, bimodal, and rectangular. Okay, let's take a look. In a normal distribution, normal curve, a bell curve, the mean and the median and the mode are all going to be in the same place. In a bimodal distribution, there are going to be two modes at the peaks, just like I showed you on a couple of slides ago, and the mean and the median are going to be right in the middle. And in a rectangular distribution, there's not going to be any mode, because they're all the same, and the mean and the median are going to be the same. So if we have a positively skewed distribution, in other words, tail to the right, the mean is going to be greater than the median. Okay, in a negatively skewed distribution, the mean is going to be less than the median. Okay, and just draw it out. We're starting from 0 here, 0 here, so we could, as we go farther down the this axis, we're going to be increasing in numbers. So just remember it that way. When the data is negatively skewed, remember, tail to the left, the mean is less than the median. And when the data is positively skewed, with the tail to the right, the mean is going to be greater than the median. And basically, if the mean is less than the median, the observations trail to the left. If the mean is greater than the median, the observations trail to the right. And try to visualize that, or draw it, as a matter of fact, on a graph. And we will now pop over to variability in the next lecture.